exciting deep dive for you all today. And this one is really going to blow your mind.
Yeah.
It's a story about medical breakthroughs, the kind that give you chills.
I know what you mean.
We're talking about the possibility of walking again.
Right.
After paralysis from a spinal cord injury.
Spinal cord injury.
Spinal cord injuries, yeah. I mean, this has been the dream for so long, right?
Absolutely.
And we're finally starting to see some real progress.
It's incredible, isn't it?
And it's incredible, yeah. I mean, we have not one but two patients who were wheelchair bound for years. And now they're walking, they're climbing stairs.
I mean, can you imagine?
It's hard to even imagine, right?
Yeah.
So today, we're going to take a look at how scientists figure this out.
Okay.
What's involved in this treatment and what it could mean for the future. Are you ready to dive in?
Let's do it.
Okay, so first things first, can you give us a quick rundown on spinal cord injuries?
Sure. So basically, the spinal cord is the superhighway of nerves that carries signals back and forth between the brain and the rest of the body.
Right.
When there's an injury to the spinal cord, it's like that highway gets blocked.
Okay.
Those signals can't get through.
Gotcha.
And depending on where the injury is and how severe it is, it can lead to all sorts of problems, including paralysis.
Right. And that's where our actually 1.5, I guess is the best way to put it, stars of the show come in.
1.5. That's funny.
Yeah. Because we know the name of one of our patients, Wolfgang Jaeger. He's 54.
Right.
But the other patient has chosen to remain anonymous.
Yeah, that's there.
Totally.
Yeah.
But both of them, they were paralyzed for years because of these spinal cord injuries, and their lives have been completely transformed by this new treatment.
It's amazing, isn't it?
It is, yeah. And Wolfgang, he said something that really stuck with me.
Oh, yeah. What's that?
He said, if I want, I can walk a little bit or go up and down the stairs, or if I need something in the kitchen where I have to stand up, I can do it.
Wow. Just the little things we take for granted, right?
Exactly. The things that, we probably don't even think about. Standing up to get something out of the cupboard.
Yeah. I mean, that's freedom right there.
It is, yeah. And so how did this even happen?
Well, it all started with some pretty groundbreaking research at the Swiss Federal Institute of Technology.
Oh, okay. I've heard of them. EPFL, right?
That's the one, EPFL. They were doing work with mice and rats, trying to understand how walking works at the neural level.
So like mapping out the brain and all that.
Yeah. They used AI to help map the specific neurons involved in walking.
AI, that's pretty high tech.
It is, but what's really fascinating is what they discovered.
Okay, what did they find?
So they found that the key to regaining movement after a spinal cord injury might not be in the spinal cord itself.
What? Really?
Yeah, it's actually in the brain, specifically an area called the lateral hypothalamus.
The lateral hypothalamus.
You got it.
I feel like I've heard of that before, but I'm blanking.
Well, it's not exactly a household name, but it plays a big role in things like arousal and motivation.
Arousal and motivation. What do those have to do with walking?
Right. It seems kind of strange, doesn't it?
It does, yeah.
A lot of scientists were skeptical at first, too, but the EPFL team, they kept digging, and they were able to prove their theory.
So how do they do that?
Well, long story short, they found that stimulating this area, the lateral hypothalamus, in paralyzed animals actually helped them regain some ability to walk.
So hang on, they were stimulating the brain.
Yep.
And that somehow helped the animals walk again, even with damaged spinal cords.
Precisely.
Wow. Okay, that's amazing. But how do you even stimulate a specific part of the brain?
They use a technique called deep brain stimulation.
Oh, deep brain stimulation. Now that rings a bell. Isn't that used for Parkinson's?
Exactly. It's been around for a while and it's been really successful in treating Parkinson's disease.
Okay, so that makes sense.
Yeah.
But using it for spinal cord injury recovery,
it's next level stuff, right?
Yeah, it is. So how does deep brain stimulation actually work in this case?
Well, basically, they implant these tiny electrodes into the brain, and these electrodes, they target the lateral hypothalamus.
Okay.
You can kind of think of them like little pacemakers for the brain.
Pacemakers.
Yeah, they send out these electrical impulses that help reestablish the connection between the brain and the nerves in the legs.
So they're like bypassing the damaged part of the spinal cord?
Exactly. They're creating a new pathway for those signals to travel.
That's incredible. But I have to ask, what's it like for the patient to go through this procedure? I mean, brain surgery, that sounds pretty intense.
It is intense, but believe it or not, they actually do the procedure while a patient is awake.
Awake? Really?
Yeah. You might be thinking, why in the world did they do that?
Yeah, why?
Well, it's actually super important because it allows the surgeons to pinpoint the exact location in the brain that they need to stimulate.
Oh, I see.
They can actually talk to the patient, ask them how they're feeling, adjust the stimulation levels in real time.
That's wild.
It is wild, and the results, well, they're pretty mind-blowing. One of the surgeons, Professor Jocelyn Block, she described the first patient's reaction. As soon as they turned on the stimulation, the patient said, "I feel my legs."
Wow.
And then when they increased the stimulation, he said, "I feel the urge to walk."
Just like that.
Just like that.
So I'm still wrapping my head around this. Stimulating motivation somehow triggers the urge to walk.
It's pretty remarkable, isn't it?
It is, yeah. So how does this actually work? What's going on in the brain and the body?
Okay, so it seems like stimulating the lateral hypothalamus, it doesn't just act on its own. It actually activates this whole network of other brain areas.
Okay.
And those areas are all involved in movement. And together, they're able to send signals down intact nerve fibers in the spinal cord.
So are you saying that there are still some working nerve fibers even after a spinal cord injury?
Exactly. And these fibers, they're like these little detours, right? They bypass the injury and allow those signals from the brain to reach the legs.
Okay, that's starting to make more sense.
One of the lead neuroscientists on the project, Professor Grégoire Courtine, he put it this way, and I love this quote. He said, "The research demonstrates that the brain is needed to recover from paralysis."
The brain is needed to recover from paralysis. That's powerful stuff.
It is, right? It really challenges our old assumptions about spinal cord injuries and what's possible.
So it's not just about fixing the spinal cord itself.
Right.
It's about reawakening the brain's ability to control movement.
Absolutely.
Okay. So this is huge, right?
Yeah.
But let's be real for a second. These patients, they aren't fully recovered, are they?
That's true. They still need assistance to walk using a stick or a walker, and they can only manage short distances at this point.
Okay, so it's not like they're suddenly running marathons.
Not yet, at least.
But still, I mean, they were completely paralyzed before this.
Exactly. You can't lose sight of that.
Yeah, that's true. So this is still a massive leap forward.
It really is. And the best part,
What's that?
the potential is enormous. Researchers are already looking at ways to combine brain and spinal cord stimulation
Oh, interesting.
to try and enhance recovery even further.
So you'd be hitting it from both angles.
Exactly. Stimulating the brain and also working directly on the spinal cord.
Wow, that's incredible. It really makes you wonder what the future holds for people living with paralysis.
It does, doesn't it?
I mean, could this breakthrough actually lead to treatments that fully restore walking ability?
It's certainly a possibility. And you know, Wolfgang Jaeger, he's a pretty optimistic guy. He said, technology is getting better and better. In the future, I think we won't need a wheelchair again. It's a long way, but I think the dream comes true.
It's so inspiring to hear that kind of hope, you know?
It really is.
So let's recap. What have we learned today? We've learned that the lateral hypothalamus, this part of the brain that we associate with things like arousal and motivation,
Right.
well, it plays a surprising role in walking.
Uh-huh.
And that deep brain stimulation, which we've already been using to treat things like Parkinson's,
Yep.
well, it can actually help reawaken those connections between the brain and the legs.
Probably.
And most importantly, I think, we've learned that the brain itself is a key player in paralysis recovery.
That's the biggest takeaway for sure.
Yeah. It's not just about fixing the spinal cord. It's about retraining the brain, helping it take back control.
Exactly.
And this really makes me wonder about the future. I mean, what other neurological conditions could we potentially treat using similar techniques? I mean, we're talking stroke, multiple sclerosis, cerebral palsy. The list goes on and on.
It's an exciting time for neuroscience, that's for sure.
It is. And remember those intact nerve fibers we talked about? The ones bypassing the injury in the spinal cord?
Yeah.
What if we could somehow encourage those fibers to reconnect with the damaged section of the spinal cord?
That's a great question.
Right. I mean, if we could restore that original pathway, the potential for recovery would be even greater.
Definitely. It's like we're just scratching the surface here. There's so much more to explore.
Absolutely. Well, that's all the time we have for today's deep dive.
Already.
I know, right? Time flies when you're having fun and learning about mind-blowing medical breakthroughs.
Oh, I know what you mean.
But thanks for listening, everyone, and we'll catch you next time for another fascinating journey into the world of science and discovery.
See you then.
Bye.
Bye.